Let's take a look at the odd-even technique, and you might have to use this. You don't have to, but this is when there's an odd number of elements on one side and an even on the other. You want to multiply out everything by 2 in order to make everything even, because if you have a subscript of 2, such as if you have a 5 oxygen and then you have an O2 here, or if you have say 5 oxygens on this side as an O2, you want to multiply it out by 2 to get rid of that odd number. And we'll show you an example of that. And you can change the individual coefficients later, and you can also reduce later. So you can change the coefficients in front of anything later. It doesn't have to stay that way. It just makes it easier to see if you multiply things out by 2. And by reducing later, what I mean is if you have something such as a 8x plus 6y 2 goes to 12xy, and that's not balanced, but let's just, this is for argument's sake, if we can reduce by, let's see, 2 here, we can divide everything by 2, so that will change this to a 4, a 3, and a 6. I'm just going to be doing balancing examples, so if I were you, I'd try and balance along with me, or stop the tape and balance it yourself and see what the answer is. Okay, let's go. Alright, so I see that we have 1 carbon here, 1 carbon here, 4 hydrogens here, 2 hydrogens there, 2 oxygens there, 3 oxygens here. So here we have an example of a odd number of, there's 3 oxygens here and 2 oxygens here. So let's just try multiplying it out. Now you can do this at any point and you don't even have to do it. But I'm just going to throw everything with a 2. And again, I can reduce all this later. But it just makes it much easier with even numbers. So we have 2 carbons here, 2 carbons, those are balanced. Hydrogens, 8 hydrogens here, 4 hydrogens here. Let's just make this a 4 now. So there's 8 hydrogens here, 8 hydrogens here, that's balanced. The oxygen though, we have 4 oxygen on this side, plus the 4 oxygen here. That's 8 oxygen, and now we can just change this to a 4. So this is balanced. We have 4 oxygens here times 2, it's 8 oxygens. There's 2 and 2, 4 oxygens, plus the 4 here. And what we can do is just reduce it now, divide everything by 2. Okay, and we're still balanced. So that's one way we could do it, just like that. Or we could have just tried it, go ahead and try to balance it without multiplying everything out by 2. Sometimes they'll just become balanced by themselves. So if we look at H4, and we could put a 2 here, so that's 4 hydrogens, 4 hydrogens. And now this is a 2 oxygens here, plus 2 here. That means it's 4 oxygens on this side. And let's put a 2 here. So either way, we could do it that way. We can multiply out first by 2 and then reduce later. In this case, it works out if you don't even have to bother multiplying it out by 2. It just worked out that way. So if you find yourself in one of these situations where it's really difficult to solve because you have an odd on one side and then even on the other, then multiply it out by 2. But really what you can try and do is first balance it out, try balancing it out, and then after you try and balance everything, then you still have that odd even thing, then multiply out by 2. But either way, it works. About this next one, well, one sodium here, one chlorine here. Well, that's balanced. Now, well, one thing I just want to mention, if you see a 1 here, it's the same as having nothing there. Now, when I say nothing, it's not a 0. It's 1 or that. And usually you don't have zeros, or usually don't put 1s there, but you can if you wish. Let's look at this next one. Al and O2, this doesn't look too difficult. Al2O3. Okay, let's do this one first. Save this one for last. Al2O3. 2 aluminums. Let's do the oxygens. Here, I'm just going to flip lowest common multiple, 2 here and a 3 here. So that makes 6 oxygens on this side, 6 oxygens there. And 2 plus 2, 2 times 2, that's 4 aluminums. So, nice, I can easily put a 4 there. And now we have a balanced reaction. I love seeing these. It makes it really easy at the end. Doesn't affect anything. Okay, what about this next one? N2 plus H2 goes to NH3. Well, we have 1 N here, 2 N there, 2H, 3H. Let's try the H's. It's a little more complicated there. Let's just swap these. So we have 6 hydrogens. Hydrogens are balanced. 2 nitrogens and 2 nitrogens. Well, that was easy. That's all balanced as well. Let's go to the next one. Carbon monoxide. So 1 carbon, 1 hydrogen, or 2 hydrogens. There's 8 carbons here. 1 oxygen, 1 oxygen. 20 hydrogens on this side. So let's just try with the carbons. There's 8 carbons there, and so that makes 8 oxygens. We'll put an 8 there. So this makes it 16 hydrogens plus 18 hydrogens. 16 plus 18 is 34, I believe. And so then I just have to put a 17. I think 16 plus 18 is 34. And that should be balanced. Sometimes you're going to get weird looking things like that. That worked. It just takes practice. Keep doing it over and over.